Guys, welcome back to my YouTube channel. This is Trigonometry NCV Level 4. Question 2 again, we are still under trigonometry. Question 2 given 2.1. It says, without using a calculator, determine the following sine 105. So, okay, enough for stories. Let us attack our question there. We are given sine, we are here. We are given sine 105 degrees. This is the same as what you can when the angle is greater than 90, we reduce it. When the angle is greater than 90, we reduce it. Right, use the cast diagram. So you know, if you have this is 90 is 8 is 90 is 180, so 105 lies on the second quadrant, with by it's 180 minus theta, we know that. So yeah, this will simply equals to sine 180. Let me check. When I say 180 minus 105, what I will have 75. Okay, this minus 75 degrees. This is simply equals to sine is positive there, the 45 degrees. But however, we will suppose when you have something like this is less than 90, but we cannot just leave our answer here, guys. Don't leave your answer. So you know what, I'm done. Still you have sine. You're not yet done there. Simplify that. If you can say use it without using calculator, that means must continue. So can say sine 75 is the same as, you can say 45 plus that. You see, when you add this, will give you 75. So it did not change anything so far, but however, we know this is what compound angle, so of sine. So yeah, since you have the compound angle, this will be simply equals to sine 45 degrees, not 48, 45 degrees multiplied by cos 30 plus, because you have that plus, plus cos, we take the one that you've started with, 45 multiplied by sine 30 degrees. You're right. So these are special angles. Then we have sine 45 and that thing there. So these are special angles. This is the same as 1 over square root 2 multiplied by cos 30, right? Whereby this is square root of 3 over 2 plus we have cos 45, whereby this is 1 over square root 2 into sine 30 is 1 over 2. I'm sure about that confidently. So this is 1 over 2. This is what we have so far. Then we multiply, that will be square root of 3 over 2 square root 2 plus multiply, that will be 1 over 2 root 2. When you multiply these two, then this is the same. Since are the same, when we are simply take square root of 3 plus 1 over 2 root 2 over 2 multiplied by root 2. But however, on the denominator, you cannot have, you are not allowed to have sets or the square roots like that, or it's same. If we don't allow to have square roots, things like complex numbers, imaginary values, here we don't have, must not have these things. Suppose if you have something like this, is either multiplied by conjugate or multiplied by itself as it is. So here I will multiply this by square root of 2. I want to eliminate that square root on top. What you do in the bottom, you also do on the top. what you do on the left hand side also do on the right hand. It's just a rule of maths. So this will goes there. Because you have two terms, I'll multiply that. That will be same as, this will be 6 plus root 2 all over 4. You might ask yourself, oh, what's going on? So how come you must ask yourself, how come you got square root 6? Just apply this rule. When you have the square root of a multiplied by the square root of b, you take what is in, because these two things, both of them, they have square root, right? Since they have square root, you can simply write the big square root and multiply what is inside the square roots. It's a multiplied by b. So is what I did there. We had square root of 3, right? Then I multiply by the square root of 2. So simply take the square root, then multiply what is inside. This is simply what, 6. So yeah, then here, as you can see, if you have a square root of a multiplied by the square root of a, we'll simply get what? A. If you multiply the square root with, if the things that are inside will be equal. For example, if you have x squared multiply, okay, if you have square root of x plus 1 multiplied by the square root of x plus 1, this will simply equals to x plus 1. Since these things are the same, you understand, if they are exactly the same. So this is what I did here. I have 2 root 2, then I multiply by square root of 2, but this is the same, right? These 2's, so that means let me keep that 2, but this one will give me what? This ones will give me 2, but I have these 2. When I multiply, I will have 4. Yeah, this is what I did there. So yeah, hopefully you understood that. Okay, it's fine. Enough for stories. 2.1.2. Oh, good. This is what we have there, minus sine squared, or sine squared 15 degrees minus cos squared. Here we have 15 degrees plus sine. There is 2 plus 2 sine x, or sine 15 multiplied by cos 15. Yeah, this is what we have. So here we're dealing with 15, 15, 15, 15. All right. Okay, guys. This is what we have there. So, I have sine squared. I have sine squared 15 minus sine squared 15. But I know this. But I know our compound angle must be equals to cos. Right? Must start with cos, must not start with sine. So I can take out the negative here in the first one, like this part here. You see, you can take out the negative outside. I don't know what I will have if I take out the negative. I'm just taking out the negative there. If I take out the negative, since I have the negative, remember is this from here, I will just take out the negative. If I take out the negative there, don't know what I will result with. When I take out the negative, here we'll have what? Sine squared 15. Then I take this negative out, we'll have plus cos squared 15. Oh my god, this is 1. Oh, plus 2. This is simply just a double angle, guys. Okay, this will be cos, if you know, 2 plus what? 15 times 15, simply date. So without wasting of time, you can just say cos 8 degrees. So this we know will be minus, but this is 1, guys. So this multiplied by 1 will be 1 minus cos 3x. Here I have minus 1 minus, this is a special angle. Cos 8 is simply a special angle, which is the square root 3 over 2. Then let's play around with our math. Right, so I can simply, this is the same as over 1. We'll multiply there by 2. We'll have minus 2 over 2 into root 3 over 2. Since the aim was to have the same denominator there, so I can have minus 2 minus root 3 over 2. This is what we have so far. Yeah, we're done there. We are here now. We have cos 17x multiplied by cos 13x plus sine 17x multiplied by sine 13x. Without going, these guys, without for me writing this, it's just a waste of time even to write this. This is a pretty straightforward, it's a basic one. Just wasting time. This you can say just equal from there. You see most 17x also 13x, so it's just simply just a double angle of what, of course. You can write only here. This will take what will be 17. Change the sign here, will be minus 17x here, be minus 13x. This is a basic one. Yeah, 13 minus this will have what when subtract 5. You understand? So this one is simply just basic. We have what, 5 or 4? Okay, 4. You'll just have 4 but for what x. It's a basic one. Yeah, 2 marks here. Just basic. Basic. So, yeah. Yeah. It's fine. We have this simply just basic 2 marks this. So yeah. So prove, we given the proof again. Cos 2x multiplied by cos x plus sine 2x squared all over 2 cos x must be equals to cos x. Show me see. This is the math. Prove this. So this is x is squared. Want to prove that, I'll say the left hand side. We have cos 2x multiplied by cos x plus sine 2x over 2 cos x. So me to prove this, let's check. Okay, this is a here I have cos. Want to prove this to cos, right? I simply want, you see I have cos there. I don't want anything that is full of sines and what. So let me, when I change this, we have 3, but I'll choose the one that has cos. I'll choose this one. I'll replace that with this one. Why? Is because I have cos. I don't want something which is full of sines, because what I have to prove is cos. So I'm on the right track. Multiply by this, the plus here. This is simply a double angle, right? So this that one would be simply equals to 2 sine x multiplied by cos x the squared over 2 cos x. So this will come, they will have 2 cos cubed x minus cos x. Then this, okay, laws of exponents. If you have 2xy, this will square the 2, square the x, square y. So this is the one and the same thing that will apply. We square everything here. We'll square this, square 2 will be 4. We'll have 4. Square sine will have sine squared x multiplied by cos squared x all over 2 cos x. So okay, this and this will divide, will have 4 divided by that will have 2. Then we have 1 here. Remember, cos squared x is same as cos x multiplied by cos x. So we'll divide 1 of that. We'll take 1 there, minus. We'll take 1 there. We'll have with just, yeah, we'll have with that. When we take the 1 there, we'll left with this. We'll cancel with another. Then the 2 will goes here, while 4 divided by 2. So actually here we'll have 2 cubed x minus cos x plus there will be 2 sine squared x multiplied by what, cos x, because here it's 1 obviously. We have this now, 2 cos cubed x minus cos x. I want to remove this because I want to prove cos, guys. So I don't want to do anything that has cos. I want to prove cos. Must try by all means to eliminate sine. I don't want anything that has sine. If you want to prove this to be equal to cos, I don't want to see sine because there we have cos. So we have to change this. I don't have choice. This will be 1 minus cos squared x multiplied by cos x. Then now we have coses. Now we are on the right track. 2 cos cubed x minus cos x plus this. Okay, so that you not confuse yourself, let me take these tools here. Let me just say 2 cos x into 1 minus cos squared x, so that you cannot confuse yourself, cannot be confused. Then distribute. Here we have minus either way. This is minus, this is minus cos x. Okay, distribute that, will have plus 2 cos x. Distribute that, will have minus 2 cos. We have cos x, the exponents will be cubed x. Right, sugar makers. This and this cancels. This, you see, this and that cancels immediately. Yeah, want to prove what cos here is cos only. Okay, it's cos. This and does cancel. You will be left with minus cos x plus 2 cos x. So yeah, this is 2. These things are the same. Here is simplest 1. Simplest minus 1 plus 2. These things are the same. Simply give us what? Give you 1. So yeah, will be 1 cos there. This will give what? Cos x. So therefore the left hand side is equals to the right hand side. Right, guys. Simple, you see. Ooh. Question 2.3, calculate the values of x given that cos x is equal to minus cos 2x minus sine 2x plus sine plus 1. So, oh short guys, as you can see, this must be, we don't know, but we have 1, 2, 3, 4 terms. Maybe might be factored by grouping if we are